Hey everybody, it's Mr. Pevy here, and in this video we're going to be talking about kind of a bunch of different types of questions that you could be asked that all kind of fit under the category of describing a function. Okay, so we're talking about graphs, and we're talking about graphs that wiggle around a lot, and a good way to think about these graphs is like a roller coaster. Okay, so if you take a look at this guy, we got a roller coaster here. It's just a part of a roller coaster. Starts at A, goes. Okay, cool. Okay. What I would like to, and that's an E, by the way. I know it's kind of hard to see. What I'd like to do is just think about how you would describe some things about this roller coaster ride. So specifically, you have to think about these three questions. Describe where the riders are going up the roller coaster, describe where they're going down, and answer the question, is there a place where the riders are neither going up nor down? Okay, so take a look at this. Think about how you describe where you're going up. Okay, I hope you're thinking like, oh, visually, that chunk's going up, but also that chunk. Both of those chunks are going up. And you'd be totally right. You'd say, where's the describer going up? From A to C, and from E to B, or E to D, excuse me. There's two different chunks where the riders are going up. Okay, where are the riders going down? Well, from C to E, and from D to B. Okay, so C to E, and from D to B. Okay. I know visually, like, totally makes sense. Is there a place where they're neither going up nor down? Not really. There's not a flat chunk shown here. Some roller coasters have flat chunks, not that many. Some of them like maybe go up and you go down and then they go flat for a bit. But there's not a flat chunk here. Okay, so, nope. This whole ride that we see here, they're either going up or down. We're going to do the same thing here with functions, but we're going to use some fancy vocab words. Okay, so first off, let's start with these three ideas. Going up, we're going to talk about it as increasing. We're going to use that word increasing to talk about when your graph's growing up. Excuse me, going up. What word are we going to use for going down? We're going to use the word decreasing. And for where the riders are neither going up or down, we're talking about a graph that's flat, that's neither going up nor down, we're going to call that constant. Okay? So the first three things we're going to talk about is how to describe a graph, specifically where it's increasing, decreasing, and constant. Okay? We do have some definitions here. Increasing means going up. But if you want to get fancy, the idea is as x, and remember we can think about x as your inputs. Okay, so as your x go up, your y's go up. Okay, as your x increases, your y increases, that creates a positive slope, sloping upward, and we say the graph's increasing. That should be pretty like intuitive, like it's what you think about increasing it. Please be sure to not get confused about this idea. Some people might look at that green chunk and say, oh, it's actually going down. No. Because you have to read these graphs left to right. Just like this roller coaster is riding left to right, and you read left to right, you have to read graphs left to right. So that first chunk is going up. You can't think about it as going down because that'd be backwards. Okay, you read them left to right. Decreasing is going down as your x as your x go up, your y's go down. Again, I just want you to remember that x's are inputs and y's are outputs. But the more important part is decreasing means going down. It means negative slope. And constant means creating a slope of 0. So it's horizontal is the other way. Okay. It happens if you have a chunk of your graph where it's completely flat. There's a couple of other things we can talk about on this graph, which is minimums and maximums. And this is kind of a confusing idea. But if I said, what's the maximum of the graph? I hope you say, no, well, C. C is the highest point. But isn't D kind of a high point too? You're like, not really. And I'm like, yeah. Why? Because if you look at D when you're riding this ride, you go down here, and then D is kind of the top of the hill. It's kind of up in the air. It's kind of a maximum. And D does count as a maximum, but we call it a relative maximum. Okay. And we called C, we would call it an absolute maximum. So absolute maximum is what you think about as a maximum. It's the highest point on the graph. Okay, and it's probably easier to talk about that first. The absolute maximum is the largest y value the function reaches. The highest point. What's the absolute minimum? It's the smallest y value the function reaches. It's the lowest point. I want to emphasize something we'll talk about more in this video, but when you talk about the absolute minimum, you're talking about the y value, not the x value. When you talk about the absolute maximum, you're talking about the y value, not the x value. Okay? Which brings the question up, like, okay, I get that. That C is the maximum. That point's the maximum. But we call that an absolute maximum. But D is still kind of a maximum because it's higher than the other points around it. See how that's the top of a little hill? Because of that, we kind of count it as a maximum, but like a mini maximum. And we call that a relative maximum. So a relative maximum is a y value that's greater than all other range values on the interval. Basically, it's the highest point around it. Okay, I think these like plain English definitions will help you more than the fancy one. So this is a maximum because it's higher than the other points around it. Might not be the highest overall, but if you look just around D, it's the highest point. E, and I'll erase some of this stuff so we can get kind of like a all cleared up here. E would be a relative minimum. Okay? It's not the lowest point. Point B is lower. But if you just look kind of around point B, it's lower than all the other points around it. And because of that, we call it a relative minimum. Okay, so a relative minimum is the lowest point around it. Okay? And again, when you ask for relative minimum, you state the y value, not the x value. Okay? Really important note. If something is asking you where something happens, like where is it increasing, where is it decreasing, you're talking about x values. Where is the x? Where refers to x values. Okay? If they ask you what's the maximum or minimum value, like not where it happens, but what is it, they're talking about a y value. Okay, so if you hear that word maximum or minimum value, they're talking about a y value. Okay? Versus where something happens, just talking about x values. Okay? So if you go back here and you look back at our roller coaster here and you forget about like the A, B, C, D stuff and you just look at like, actually, you know what'll be easier? Let's skip to the next one. This will be easier, actually. Let's look at just this other graph here. I think this will be easier to do it for this one, okay? So if we look at this graph, we're going to try to figure out where it's increasing, where it's decreasing, where it's constant, where the maximum value, or excuse me, where the maximum value is at, what it is, blah, blah, blah. We're going to figure out all this stuff, okay? Let's start with increasing and decreasing. It helps me to do the shading. So where is this graph going up? If I read from left to right, it's going up here, and it's going up here. Where is it going down? Here. What about this chunk? That's the flat chunk. Okay, so if I want to describe those green ones, I'm going to describe the x values. So I'm going to say from x equals 0 to x equals 1. And we're just always going to use parentheses. For increasing, decreasing, constant, all parentheses. No brackets. So where is this increasing? From 0 to 1. But also, oops, sorry, from 2 to infinity, all the way to the right. We have two little chunks that we're putting together. We use that fancy U. It stands for union. Okay, so it's increasing from 0 to 1 and from 2 to infinity. What is it decreasing? X values. How far left? All the way left. How far right? Does it stop decreasing? It stops right there, which is an x value of 0. And we're using all parentheses, and we're talking x values here. Between what x values is it constant? Between an x value of 1 and 2. So where is it constant? From 1 to 2. Okay? You guys all good? Okay. Let's talk about relative maxes. Is there a point on this graph that's higher than all the other points around it? Not really, okay? So there isn't really a relative max on this graph, okay? Is there an absolute max? Is there an actual point on this graph that's higher than all the other points? No, because it shoots up to infinity. So neither of these things, no, it keeps going higher and higher. There's no absolute max. What about minimum values? Is there a lowest point on this graph? Well, yeah, there actually is. This point. Now, is this a relative minimum or or an absolute minimum? It counts as an absolute minimum. That's because it's lower than all the other points in the graph. See how that's the very bottom of the graph? So the absolute minimum here, I'm sorry, let's cross this out. This is going to get a little confusing. Sorry about this. The absolute minimum, there's two questions they're going to ask. Where does it happen? At. And what is the actual value? Okay. Where does it happen at? Well, what x value does the minimum happen at here? Excuse me. It happens at an x value of 0. Where does it happen at? Here. What is the y value at that x value? Well, for this one, it happens to also be 0, so it's kind of hard to see that. But for the value, we're talking y, so the minimum value is y equals 0. Last thing is domain and range. We talked about this already. How far left, how far right. This graph goes all the way left and all the way right. Excuse me. Off to the left, it goes off to the right. So our domain is going to be negative infinity to infinity. Little parentheses there. Range, remember range, you got to do bottom to top. What's the lowest it goes? 0. What's the highest it goes? Well, it shoots up to infinity. So your range is going to be 0 to infinity, and it actually hits 0, so I'm going to put a bracket there. Okay. We'll practice this. I know there's a lot of stuff going on here, and it's confusing, but we'll practice this more. Cool? All right. That concludes this video. Thanks for watching, guys.